Welcome, mathematicians. In this video, we're going to work through solving a few proportions together. Before we get started, if you haven't had an opportunity yet to solve each of these three proportions, pause me and then come back to check your solution. Here are the solutions. The rest of this video is I'm going to walk through each of the proportions. I'm going to show you two ways to solve this one, two ways to solve this one, and I'm going to focus on one way to solve the third one. So skip around and watch the proportions where you need to see some instruction. Before we solve this first proportion, let's remind ourselves of the three basic strategies we can use to solve a proportion. We can use equivalent ratios, we can treat the proportion like an equation and use algebra to isolate the variable, or we can use this special, a little bit of a shortcut called the cross product. For any proportion, I first see if I can use equivalent ratios right away, and I'm looking for any relationships between the numerators, the denominators within one side of the proportion, and I see very quickly that I could take 3 and multiply it by 12 to get 36. Because this is proportional and these are equivalent fractions, because they're in a proportion, I know if I take 12 and, x and multiply it by 12, I will get 7. I could say I have x multiplied by 12, and that's going to equal 7. I can take this equivalent, simpler equation now and isolate x by dividing both sides by 12, and x is equal to 7/12. In algebra, we just prefer keeping things as fractions. You don't need to turn it into a decimal or anything, and this is telling us that 7/12 is to 3 as 7 is to 36. They have that same, they're equivalent fractions. Let's look at a different strategy we can use. We could also, to solve this, use algebra. When I'm using algebra, I'm treating this proportion just like an equation. I notice x is being divided by 3, so I'm going to multiply both sides by 3 to undo that division. All right. Now I could just multiply 7 times 3 and get 21 and get 21/36, but then I have a fraction that I need to simplify. To be more efficient, and mathematicians are always trying to be efficient, is I'm going to simplify this fraction before I multiply. I see that both the numerator and the denominator have a factor of 3. So 3 divided by 3 is going to give me 1, and 36 divided by 3 will give me 12. So doing this, I simplify first, and then I get 7/12. And I know my solution is fully simplified. To solve this next proportion, I'm going to use two different strategies, algebra and cross product. As mathematicians, we always like to see, can we solve things multiple ways? And you might be like, well, why aren't you using equivalent ratios? Well, when I look at this, I don't see any relationships between my numerator, my denominator, or within. So I'm not going to use the equivalent ratios. Instead, let's start with algebra. Now, the first thing that's really causing me a little bit of concern is the fact that my variable is in the denominator. So 12 is being divided by x. So how do I undo that? What do I do? Now, because I can do anything to this equation as long as I do it to both sides, I'm going to start by taking the reciprocal of both sides of the equation, of the proportion. And that will leave me with x divided by 12. X is to 12 as 8 is to 5. And I breathe a little bit of a sigh of relief because I'm like, okay, my variable is now in the numerator. It's being divided by 12. I know how to undo that. I'm going to multiply both sides by 12. 8/5 divided by 12. Before I do my multiplication, I'm going to look and see, are there any common factors between the numerator and the denominator? Because I want to simplify first. There are not. So let me do the multiplication. 8 times 12, I think of that as 8 times 10 is 80, plus 8 times 2 is 16. 80 plus 16 is 96/5. And there's my solution to the proportion. Right, let's look at the cross product. And I'm going to just remind you, with the cross product, what's really happening is the cross product, we want to clear the denominators. And I'm just going to show you, to clear the denominators, we'd have to multiply both sides by 8 to clear the right denominator. And we'd have to multiply both sides by x to clear the left denominator. All right, and we see that x and x, they divide out and left with 1s. 8 and 8 divide out, we're left with 1s. And when all this is finished, we're left with 8 times 12 is equal to 5 times x, or 96 is equal to 5x. My last step, x is being multiplied by 5, so I'm going to divide both sides by 5 to get 96/5 is equal to x. Typically, when you're doing the cross product, you don't show this step. Let me just show you a different notation. Sometimes I see people do this. I'm not quite sure how I feel about it, but I'll show you. Is they say for the cross product, we're multiplying the numerator by the denominator sort of across the proportion. 12 times 8 is equal to 5 times x, and go from there. 96 is equal to 5x. So again, this notation, I don't know. Again, I feel mixed about it because it sort of feels like magic. And just knowing that behind the scenes, this is really what you're doing. All right, let's end by looking at this last one. Sometimes people look at this proportion and they have a little moment of being like, I'm totally stuck. I have no idea what to do. Let's just go back and just remind ourselves, let's see, can we use equivalent ratios? There's no real relationship I see between my denominator, my numerator, or within the fractions on either side, so equivalent ratios is out. Let's think about algebra. I could use algebra for sure, but this is a little bit unusual with variables in the numerator and the denominator. I might not know exactly where to start. This one might be just a great candidate for using the cross product. And the cross product, as a reminder again, is we are clearing the denominators. I am not going to show the behind the scenes steps right away, just so you get a feel of how the cross product works. So you're going to multiply the numerator on one side with the denominator on the other, and that's going to be equal to the numerator on the other side with the denominator. So that's going to give us 3 times x is the same as 2 times the entire denominator, x minus 1. And that's what we officially call the cross product. From here, I'm going to simplify the right side by distributing. I'm going to combine my variable terms on the left side, so I'm going to subtract 2x from both sides, and I'm left with x is equal to -2. All right, just a reminder, what's going on behind the scenes to get from this step to this step is we're multiplying both sides by both denominators. So we're multiplying both sides by 3, and we're multiplying both sides by x minus 1. I'm just going to put that in parentheses to remind that we're multiplying by the whole thing. And then those denominators divide out because they're the same. These denominators divide out, and we're left with 3 times x is equal to 2 times x minus 1. Again, when we do the cross product, we typically don't show this step. Feel free, if it helps you understand, do it. We typically just go from here to here. All right, I hope this video has helped you think about different ways to solve proportions and our 3 basic strategies and how we might use them in different situations. All right, see you again soon, mathematicians. Bye-bye.